Welcome to another Intermediate Algebra video. Today we're going to look at two different things, solving for a specific variable and then using formulas to find a solution. And so here are our objectives: solve for a specified variable and use formulas to solve problems. So these formulas could be anything, and in the video we're only going to see one specific formula used. It's a very popular formula for this type of question, but it could involve anything, so just be aware that on the homework there might be a few variations of formulas given, but we'll talk about that when we get there. Okay, some notes for this video. The notes for the first objective, being solve for a specified variable, the notes really only are that they're the same equation solving techniques that we saw in an earlier video for solving linear equations. And then for the second objective, using formulas to solve problems, the formula that we're going to focus on is the compound interest formula. So here we have the formula itself and then what each variable in the formula stands for. So we will be given a word problem with information about a certain scenario that will use this formula, and it'll say using compound interest potentially somewhere in the equation or in the problem itself. And we'll have to assess and find at least 4 of these variables to be able to plug numbers in for. And once we do that, then we'll be able to solve for the missing variable. So let's start with that first objective. Solve for y. The given equation is 3x plus y equals 4. If we want to solve for y, our ultimate goal is to get y by itself. So we want to undo everything happening to it. In some cases, that'll be more complicated than in others. So for this problem, the only thing that's happening to y is that 3x is being added to it. And just like we saw in the video on solving linear equations, to undo addition, we subtract. So we'll subtract the term 3x from both sides of the equation. On the left, they're gone. We're left with just y equals. On the right, we have 2 terms that don't combine, which is okay. 4 minus 3x. And our last step is to always make sure, when we're solving for a specific variable, that the variable is isolated. So we have y equals blah, blah, blah. We've solved for this variable. A couple of things to point out. It would also be okay if you had written these 2 terms in the opposite order. This is probably a more standard way of writing a problem with the variable term first and then the constant, but it doesn't matter. If you wrote it the other way, completely fine. Any homework system, any test would allow either one to be the final answer. What's important to note in differentiating this type of problem from an earlier type of problem where we just solved the linear equation is that we are not getting y equals a number. We're getting an equation. We're solving for a variable so that we could use this equation. Maybe in this scenario, we had a bunch of information for x, and we wanted to know for every different scenario what y would be. So if we had all that information and we solved for y, we could just plug in for x, multiply, add, over and over and get all of that data quicker than if we were to plug the information in here and have to do a little bit more equation solving to get the answer. Truthfully, it would be about the same amount of steps, but it's definitely easier to look at it this way. So either one of these, completely fine. This one had 1 step. This problem had 1 step. It might take a few more steps in some problems to get there. So let's see another one. All right, let's say we want to solve for a in the equation j equals ac minus 5. The goal is still to get a by itself. The variable we're solving for is a. So we have to look at what's happening to a. It's being multiplied by c, and 5 is being subtracted from it. So we have to undo both of those things. The question is, in what order? If we follow the steps from the solving linear equations video, we know the first step would be distribute, combine like terms. There's nothing like that we can do in this case. It might happen in other cases. But the next thing is to undo addition and subtraction. So we will do that in this problem. We have subtraction. We'll undo it with addition. So on the left, we have j plus 5. On the right, we have AC. Negative 5 plus 5 is gone. And our goal is still to get A by itself. So the last thing we have is A being multiplied by C. We'll undo that with division. And there's a couple ways you could look at this. A equals J plus 5 over C. This is one way to view this final answer. And at this stage, completely fine to see it this way. An alternative way to see this answer, the step is still the same at this stage. Now, if we're still at this stage, our objective is the same, so we're still going to divide both sides by C, but we can make the decision to divide the entire left side by C or to divide each individual term by C. We have the same result on the right, which is good. That's what we want, A equals. But on the left, our solution looks slightly different, yet it represents the same information. This is sort of like seeing the problem where you have like fractions that just haven't been combined yet. And for now, either one is completely acceptable. We'll get to a point in this class where the first is preferable, and we'll get to a point where the second is preferable. It just depends what information we're dealing with. So just keep in mind that either of these answers would be completely okay. Something else to keep in mind, if you're typing a solution like this first one into the homework system, if you type J plus 5 divided by C, what the computer is going to read is that only the 5 is being divided by C. It doesn't recognize that everything is in the numerator. So the way that you'll tell the computer everything's in the numerator is with parentheses. Parentheses around J plus 5 and then C in the denominator. If you felt the need, you could also add parentheses around the denominator. You can default to always putting parentheses around both numerator and denominator, but it's only necessary when there's more than one term. Only when there's more than one term. J plus 5, two different terms. And this one, if you typed it in, it wouldn't give you any issues because each fraction only has one piece on the top and bottom, but they represent the same information. All right, let's see another one. Okay, let's say we want to solve for B in this equation. T equals C times the quantity 2 plus AB. Now, if we go back to those steps for linear equation solving, the first step is distribute. And so that's what we're going to do. Distribute the C to this parentheses. We have 2 times C. If you wrote this as C2, that's fine. Plus C times AB. I'm going to write them in alphabetical order, A, B, C. They're all being multiplied. It doesn't matter which order you write them in. I'm going to choose alphabetical. If you put a different order, it's fine. Okay, second step is combine like terms. These are not like terms, so we can't combine them. Then we start undoing operations with the ultimate goal of isolating B. So we have stuff being multiplied by B, A, and C, and we have a term being added to it. So we'll undo the addition subtraction first. Minus 2C from both sides. T minus 2C equals ABC. If you flipped these terms, negative 2C plus T, same thing, that's okay. And then our last step is to undo the multiplication. This one looks a little different because we have 2 things being multiplied by it, but it's fine. We can undo both of them at the same time. Undo with division. So if I choose to leave it underneath everything, A and C, gone, we have B equals T minus 2C over AC. This is one way to view this solution. Or if we chose to look at it the other way, the second way we saw in the previous one, where we divided each individual term, We still have b on the right-hand side, which is good. Our ultimate goal is to get down to b equals something, if that's what we're doing, if we're solving for b. But then this time on the left, we have t over ac, and 2c over ac, well, we can divide out a c from top and bottom, leaving us with 2 over a. This would be another way to view this solution. And if you chose to separate into 2 different fractions like this, and I say 2, this example has 2. If there were 3 terms, you'd have to do it to all 3. If there were 4 terms, have to do it to all 4. But if you choose to go this route, then you would need to simplify each individual fraction, leaving you with this answer. You might be wondering, this is a question I get a lot, from this first solution, would it be all right if I canceled the c from the top and bottom? And comparing, you can see that it looks like that might be okay, but it wouldn't work out. Since the c is not also part of the t, you can't cancel it out. The only way you could cancel it out is if the t also had a c. For example, if this was what you had, and then you factored out, we're not at factoring yet, don't worry, this is just so you can see why it wouldn't work out. If you're not following, just don't cancel out unless they're individual. But only when things are being multiplied, c is being multiplied by this term or by this factor t minus 2. Only when there's multiplication can you do the opposite and divide. In this case, it's only subtraction happening, so we can't cancel this c out. Only in this case could you, but this has nothing to do with the problem that we just did. This was just a side example. So either of these 2 solutions would work. This is an equation for b. b equals everything else on the other side. Okay, all right, I think one more. Oh, not one more. Okay, so let's look at the other type of problem that we're going to look at in this video, which is using formulas to solve problems. So we have a word problem. Tori wants to invest $5,000 in an account that pays 8% compounded weekly, monthly, or quarterly for 6 years. How much will be in each account after 6 years in each scenario? How much will be in the account? Excuse me. So this problem wants us to use the interest formula. Let's refer back. This compound interest formula. So I'm going to copy the formula at the top of that slide. We have what each variable represents. A represents the amount in the account after t years. P represents the principal, meaning the initial amount. R represents the interest rate as a decimal. T, the time in years. And N, the number of times that it's compounded in a year. So we have here's our formula. Okay, so the question is asking us to find out how much would be in the account in 3 different scenarios: weekly, monthly, and quarterly after 6 years. So let's identify what some of those variables represent. And then start plugging things in. As I mentioned before, we should be able to find information for 4 of these 5 variables. The only way we can solve is if we know 4 numbers here. Okay, so the first information we're given, Tori wants to invest $5,000. Investing $5,000 is the principal. That's the initial amount. This formula is interesting because it can be used in both the good and the bad scenario. In this case, someone is investing money, Tori's investing money. But this formula could also be used to calculate interest that you would pay on a loan, a loan of any kind, a mortgage, a car loan. So keep that in mind when we see the solution. Okay, so she's investing $5,000 in an account that pays 8%. 8% is our rate, but we want that as a decimal. So when we plug it into the equation, it'll be 0.08, goes back 2 spots, 0.08. The money is compounded weekly, monthly, or quarterly. So we're going to make a decision based on these three things. I guess not a decision. We're just going to see how much money would be in the account in the three scenarios. So this is referring to how often the money is compounded. That's our n variable. So if it's compounded weekly, that means the first week of the year is compounded, the second week of the year is compounded, the third week, all the way through the end of the year. N means how many times it's compounded through the entire year. So if it's compounded weekly, that means 52 times a year. This is weekly. If it's compounded monthly, how many times is it compounded in a year? Well, once a month, January, February, March, for a total of 12 monthly. And quarterly means quarters of a year, so 1 quarter, 2 quarter, 3 quarter, 4 quarters in a year. 4 quarters and a dollar quarter means dividing into the fours. So 4 for quarterly. So we have for the three scenarios the different n values that we'll plug in. Now we either need to have information for the a variable, the outcome variable, or the time. Continue on. The question, how much will be in the account? That tells me that A is what I'll be solving for after 6 years. So time, 6 years. Okay, so let's run the scenario 3 different times. Let's start with weekly. All right, so the equation A equals, and plug in everything we know. 5,000 times the quantity. This is a 1, not an L if you couldn't tell. 1 plus the rate, 0.08, divided by n, in this case, 52, raised to the n times t power, 52 times 6. And there's a few different ways you can calculate this. If you're using the TI-84 or TI-83, which you should be using, you can type everything in all at once. If you don't feel comfortable typing it in all at once, then you'll have to sort of follow our order of operations, which would be parentheses, so do this division, then add, then raise that to the exponent to the 52 times 6, and then multiply that by 5,000. But it all would have to be done in the calculator. You couldn't get a number and then round, and then use that rounded number. Get another number and round. Use that rounded number. The more times you round, the bigger error you'll have in your final answer. And an online homework system is going to look for a perfect solution. And so will I. You should be typing in everything at once or just using the numbers from the calculator. Okay, so I'm going to type it in all at once. We have 5,000, open parentheses, 1 plus 0.08 divided by 52 raised to the 52 times 6 power gives us 8,077 point. Now the decimal is 392, and there's a little bit more. So the question is, where should I round? How do I know where to round? Well, what does the a variable represent? It represents the amount of money in the account. How many decimals out is money? 2. So that's where we'll round. $8,077.39. So $8,077.39. So if she invests $5,000 for 6 years, after the 6 years, the account will have $8,077.39. Pretty good if you can find an 8% interest rate. Probably not likely. But on the flip side, it's interesting to note that this formula works also for loans. 8%, I guess it could be possible. Credit cards often charge about 20 to 25% depending on the type of credit card that you're using. So if 8% causes you, in this scenario, if it was a loan, if your credit card, you charged $5,000 on it and you didn't pay it off, you just let the interest keep adding on, after 6 years, your bill without doing anything would be up to $8,077. So it's really interesting to keep that in mind. It definitely helps if you're investing, but it hurts you if you're in a loan. And that's not to say that loans are bad in any way. I currently have a mortgage. I currently have a car payment. It's part of life, but do your best to be aware what those percentages are so that you don't accrue that kind of interest over time, because it can definitely hurt. Okay, so our weekly scenario is $8,077. Our monthly scenario, let's run through that. Plugging in all these pieces, the P is 5,000 times the quantity, 1 plus our rate is still 8%, but now our N changes. Instead of 52, we have 12 raised to the 12 times 6 power. I'm going to write out what it would look like in the calculator for the third scenario. Let me get this answer and then we'll take a look at that. To the 12 times 6. All right, looks like I get 8,067.51. Looks good. That's rounded to 2 decimal places. And then in our quarterly scenario, this time our N is 4. Oops. And I'm going to write out what this looks like plugged into the calculator. And this is into a TI-84. If you're using a cell phone, which fine, but not great. Obviously it's okay for now, but on a test it's not going to be okay. You would have to follow order of operations. So this is typing it into a higher powered calculator. So we'll have 5,000, open parentheses, 1 plus 0.08 divided by 4. Nope, other way. Caret, this little caret symbol means the next thing you write is going to be an exponent. But keep in mind, since there's 2 things in the exponent, you're going to need parentheses around it, just kind of like that fraction problem. We have 4 times 6. So this is what goes in your calculator. 0.8, 4 to the 4 times 6. And we get 8,042. It's 0.186, which rounds up to 0.19. Make sure it's good. 0.84, 4 times 6. Good. So not a whole lot of variation in how often it's compounded. The interest would cause a big change, and the number of years would cause a big change. Okay, so we've seen this formula worked out 3 different times. As I mentioned, this is not the only formula that's possible for this type of problem. You could be presented any type of formula and then told what those variables represent, and then given a problem to assess, okay, what information do I have? What am I solving for? For this problem, you might be wondering, would it be possible for me to solve for a different variable? I suppose you could solve for the principal, but pretty much any of the others, we don't have the tools for it yet. That's something you'll see in college algebra. But any other type of problem, let's say you were given a question that involved the perimeter formula. This is an L. If you're given the length and the perimeter, you can solve for width. I just want to point out that it's not always going to be the case that you're solving for the variable that's already isolated. That's why we learned how to solve for a specific variable, so that maybe you could solve for that variable and then plug things in. So if we were given L and P, we could solve for W. You could go through the process and solve. That's what a different problem might look like. But this is definitely a popular one for the time being. Okay, let's do some practice problems. So here are 4 different problems, 1, 2, 3, 4. Take a couple minutes, pause the video, When you come back, I'll run through each of these with you. Remember, this practice is an important part of the process, so you should be doing these practice problems. Okay, let's look at the first one. You've gone through them all. You have all your solutions. Let's compare notes. So the first question says solve for z. Here's z. We want to isolate it. There's no distributing, no combining like terms. We're undoing operations. So we have 3 being multiplied by z and 4 being added. Undo addition subtraction first. Whoops. Minus 4. As I mentioned, if these two terms are flip-flop, that's fine. Negative 4 plus 5r. And then divide everything by 3. And you have the choice of doing individual terms or the entire thing. Either way, this is a 3. Okay, either one of these is good. Let's do the second one. Next one, solve for a. Here's our given equation. A is inside parentheses. We'll still follow those steps for solving linear equations. Distribute. I'm going to pull it over here. 5 times 2, 10, plus 5 times 10a, 50a. Solve for a, so undo everything happening to it. Subtract 10 from both sides. And divide by 50. One possible solution, or if you separate them, again, you'd have to simplify. So either this or this. As I mentioned, for the time being, if you just want to stick with this first method and not do any of the simplifying, that's fine. But pretty quickly we'll get to a point where we're doing separate division. So it's up to you. Just recognize that they are the same thing. All right, the third one, solve for p. There's only one thing happening to p, and that's multiplication. So undo it with division. You have p equals x over r. Can't think of any other way to write that one. It's as simple as that. All right. And our last practice problem. How much will be in your account if you invest $2,005 in an account earning 2% weekly after 8 years? So here's our given formula. Let's see which variables. How much will be in your account? So we're looking for this outcome variable. If you invest $2,500, the initial amount, in an account earning 2% as a decimal, 0.02, compounded weekly, how many weeks in a year? 52. I realize it's not a perfect number, 52. It's 52 point something weeks in a year, but you can assume that it's just going to be 52 if you're asked about weekly. Oh, wrong spot. Oops. That's number of years. Still 52, but it's n, the number of times compounded a year. And then t is after 8 years, so the time, 8 years. Okay, plug everything in. Times 1 plus 0.02 over 52. 52 times 8. Plug this into the calculator. We get 2933, 6.686, so that'll round up to 0.69. Again, this number represents the amount of money that will be in the account after all that time. I wouldn't be surprised if you saw a question that asked how much interest was earned. So given this is the final amount in the account, well, the initial amount invested was $2,500. So you could figure that out. And for our question, we have the final answer, but we could figure it out by subtracting out the initial amount in the account, which would give us $433.69. And just as I kind of mentioned before, in this investment scenario, this means by just having the money sit there, you earned $433. On the flip side, if your loan was for $2,500 with 2% being compounded weekly for 8 years, you'd be paying an additional $433 just for having the loan. Okay, as I mentioned, I just want to be very clear, this is not the only type of formula you could see for a problem like this. It could be a different kind, but you would be given what the formula is. You would be told what all those variables represent, just like we were told at the beginning of the video. Okay. All right, so go ahead and work on the homework, and I'll see you for another video soon.